Hello there and welcome back to ovs.net. Today it's about power supplies. So what most of you maybe already know is that the Commodore 64 takes 5 volts directly from the power supplies to the motherboard, and therefore it is sensitive for over voltage from these old power supplies. And that's exactly what can happen with these old bricks over time. The 5 volt output can actually start to increase and therefore suddenly can damage the computer. When you buy an old Commodore with these old bricks, you should always measure the 5 volt output. So now I'm gonna measure the different output voltages on these power supplies, and I'm gonna start with this new one, which is a modern switching power supply, and it also even has a voltmeter that actually shows you the current output. So this shows 5.01 volts. And by the way, this one is made by Keylog, and you can find it online. It's not that expensive, and I'm not sponsored by them. So now I'm gonna measure on the 5 volt pins, and it can be a little bit fiddly to measure and use a multimeter on these DIN plugs. So a suggestion is if you have the female part, then you can just plug it into that, and then it's easier, of course, to measure the voltages. So let's see if we can manage to get a measurement from this. And now, of course, the auto power off turns in, but before that I can now see that the output from this power supply is 5.02. Next is this old pretty damaged one. Alright, let's see what we get from this one. A little bit fiddly to make sure you're not could I use some crocodile clamps, but alright, so this actually gives out exactly 50 volts, 5.000. So that's a safe one for now. So next I'm gonna measure this one, also an old one. So let's see, what do we have? Alright, it's 5.24, and that is actually a little high. So this one I would be cautious about, because if you start to get up in the 5.3, 5.4 volts, it's a bit too high actually. Next is this one, a little bit more modern. Let's see what that has to tell us. Alright, this uses the other pin, and it's 5.19, so almost 5.2, and yeah, that's okay, I think. So as you can see, the two different power supply has the 5 volt pin on a different side of the ground pin, and so the other two pins are the AC output, and we can actually measure that too if we measure between these two pins here. And that says actually 10.8 volt AC. So it should be 9, but it's a little bit higher, but that's not a problem. The AC voltage is almost never the issue on these power supplies anyway. So even if this power supply brick is safe today, there's nothing that prevents it from suddenly starting to fail while it is connected to your precious Commodore 64. And I have actually heard tales about this, that the power supplies connected to a running machine suddenly broke down and gave out high voltage and fried the machine. Personally, I never experienced that, but you never know. So what can we actually do to prevent this? Well, here's something I got sent in the mail a while back. And I got this from a fellow YouTuber called Mindflare Retro, and some of you might have seen his videos. He's really a nice guy with a lot of good videos. And this is actually the C64 Saver. The C64 Saver is actually a little handy device made by Bwack, another fellow YouTuber. He's very good at designing electronics, and he was the guy that actually made the Commodore 64 KU motherboard replica, which I used in my building a Commodore 64 series a while back ago. So the C64 Saver consists of this little PCB and some components, and what it does, it actually prevents the overvoltage from Commodore 64 power supply to go over a certain threshold, and by doing that it actually protects the machine, and it cuts out the power if the voltage goes over the threshold. So Mindflare Retro sent me this package with the instructions on how to build it, and yeah. Now I'm actually gonna build this and take it for a little test drive. If you haven't heard about Bwack and Mindflare Retro, you should visit their YouTube channels. Really good content, and I'll link to them in the description below. So the kit is quite simple. It's a couple of transistors, a few diodes, and some resistors, and a small capacitor. So it should be easy to build this. It's through-hole components except for this transistor here. So if you go visit Bwack on GitHub, you find all the designs and the information about this project, and yeah, it is open source, so-called open hardware, and here's even information about the additional board that you can connect up to the C64 Saver to get additional features from it, like adding an OLED display and things like that. So that's really cool. So go visit his page. Now it's time to do some soldering, and I'm heating up the soldering iron, and yeah, let's go. So everything is marked with the values and the name of the component, so it should be fairly easy. I just start by cleaning the board with some isopropanol, just to get rid of any fat or dirt. So just look at this drawing from Mindflare Retro and these assembly notes, so that should be easy. Now before I start soldering in the resistors, I just measure if they are the correct value. You never know. 3.3, 3.9K. Everything looks good. I just start by the resistors are 1 through 6. Then are 8 and 7. Okay, let's do a little bit of soldering. that looks good. Next we have these two Zener diodes. Little electrolyte capacitor. Then we have this voltage regulator and transistor. Finally we have this little surface mounted transistor, and it's a little bit harder than the usual through hole, but not that difficult. I just realized I said D1 was a voltage regulator, but it's not, it's a diode. So this little guy is supposed to go up on this on these pads here, and for that I think I'll use a little bit flux. The flux even helps it to stick a little bit, so yeah, I'm actually gonna add a little bit of solder in the middle here. So now I'm just gonna keep it steady and just heat up the ground plate. So now it's sitting firmly there. So that was the circuit. Yeah, that was actually quite easy, and yeah, looks good. Maybe not the best soldering job in the world, but this will work. And then a little bit of cleaning to get rid of the remaining flux. Alright, so I nearly forgot, but you actually need two jumpers on this one, so I just made two little wire jumpers from a resistor leg or something. I just bent, and yeah, if I can make it fit, it would go there, and the other one is going up here. Alright, next is to add some wires to this little board, and I got a little 4-wire cable here, and yeah, I don't think I need any long lengths, just a little bit on each side. So I just pull out a little bit of wire, and then I'm gonna strip off a little bit. A little bit soldering. So the holes are quite larger than the wire. Just a little bit of solder on the other side as well. I could of course have used some kind of screw terminals or something, but this will do. Next is these DIN connectors, and it's a male and female of course, and this might possibly be the most challenging part, soldering DIN connectors. That's always a pain. And for the female connector I only got this type that's supposed to be screwed into a box or something, but I'll see how I'll go about this. I need to find some kind of enclosure to add it to then, but for the other side it's okay. Just gonna take off the plastic. So now I need a little case or enclosure, and I went to Thingiverse and searched for C64 saver, and there's actually 3 different models. And first I printed this one here, that's actually made by Sven Petersen, and because I thought it maybe could fit, and because the one here with the picture of the module for a OLED screen I thought wouldn't fit, but then I just clicked into this modular case, and it is actually made to fit the regular C64 saver without the hat and the OLED as well. So I'm gonna print this one now. And here it is. It's actually several different types you can print. And as you can see, this one has a hole for the DIN socket that I have, and this should fit perfect for my purpose. And this case is made by Bigby, and you can read more about it on the project he made on hackup.net. Now here comes the tricky part, to solder the DIN connector on, and yeah, the first thing you need to remember is to put the cap onto the cable before you start soldering. I have many times forgotten that and had to redo the work. And with the instruction came also a diagram of how you connect the different pins. So I'm using this helping hand, but of course I could have used the potato method that Bwack invented. Alright, let's see if I can do some magic with the one hand. Alright, so it's stuck. First one is the tricky one. Then I can free up one hand and work better. Then the white one, which is the ground. This does not conform to the standard colors of wires, but that's what I had. final wire. Alright, that doesn't look too bad. Next is the input side, in which I'm gonna solder on this DIN socket. Here's the two cases I printed, and this one is from Sven Petersen and requires that you have a cable from both sides. Besides that, it's a very good fit, and the case design is yeah, very nice. And here's the case made by Hackup, and this one has room for a DIN socket like this, and otherwise you just place it into the case like this, and I can feed the cable out here. So I need like a rubber grommet or something here, and because of that I should have waited to solder on the DIN connector. So I got a kit of rubber grommets here, but I think this one is the only one that fits this case, but it's still too large a hole. So if I put a smaller grommet inside a larger one, then it might fit. Anyway, I'm now gonna solder in this contact, and yeah, I don't need this plastic insulation for these wires, is just in the way. Alright, now let's see if we can connect the DIN socket. Alright, that was the soldering. So let's see if we can fit this board and the little contact. I didn't film it, but I desoldered the wires for the other end, and I added this double grommet. But before I close the case, I'm gonna test. So I'm gonna test it now, and I'm just plugging in one of the power supplies. So now this should give us around 5 volts out. Alright, 5.19. Yeah, so the device is working. However, this is under a normal voltage, so I'm not really sure how I'm gonna test it with a higher voltage and see if that it cuts off, because I don't have a power supply actually. That is actually one of the things on my wish list, to get myself a bench power supply. So I have to think about some way to test the overvoltage cutout function, but first of all I'm gonna test if it is actually working with the Commodore. Yeah, actually works. Well, that was expected. So now I'm gonna test the power supply that was a little bit high in the voltage and see if that works. No, seems to be cut out. So that old power supply did not work at all, and what I realized is that this DIN connector for the C64 saver is connected to pin 5. However, some of the older power supplies have the 5 volts on the pin 4. And this one actually has 5 volt on pin 4, so I actually need to connect that pin as well to the 5 volt input. So I'm just gonna make a little jumper wire between pin 4 and 5 on the DIN connector. So now pin 4 and 5 is connected, and this should work with the other power supply as well. So let's see. Alright, so now we should have 5 volts on the input. Yeah, 5.23. And also on the output we should have the same. 5.23, yeah. And the AC should be also connected through, and it should be, yeah, around 10 volts. 11. So I figured a way to test this with a little bit higher voltage. I have this battery holder here, which has 6 batteries, and it is 12 volts, but I removed 2 of the batteries, and yeah, if I connect those 2, then we have 7.9 volts out of this. So if I connect this with 8 volts, then it should cut the output voltage. Okay, so now I'm adding around 8 volts. Let's see on the input, do we have 8 volts? 7.8. And now on the output, it should have cut off so that we have 0 volts. Yeah, and it actually is. 7.7 volts in. Zero volts out. Perfect. It works. So now it's just a matter of finding the correct screws, which I think I have here, and I already started on this DIN plug. These holes, when you print on a 3D printer, is not very accurate, so there might be some leftover plastic inside holes like that. But so this was a really well made case actually. It's a little bit tight space to get the finger inside to hold the nut, but I think I managed. Alright, that's it. Finally, the lid can go on. Not sure if these screws fit or if they're maybe too small. No, seems to be a good grip on those. Yeah, that's it. Final little touch. Mindflare Retro sticker. Alright, that was it. Now it's a little bit more safer to use these old C64 power supplies. Alright, that was it for this video. I hope you enjoyed it, and thanks for watching, and thanks for subscribing. And a special thanks goes to my Patreons that already subscribed to my Patreon page. Thanks a lot. See you next time. Bye bye.